If we want to take the temperature of the air, or of the human body, or of the baby's milk, we use an instrument called a thermometer. Sometimes we want to control temperature and keep it constant. For instance, this tank contains tropical fish. The water in the tank must be kept warm, or they will die. To keep the water at exactly the right temperature, we use a regulator called a thermostat. Thermostats have many different uses. For example, in the Royal Festival Hall in London, these gas boilers, which control the air temperature in the building, are thermostatically regulated. And here, in this modern gas-fired bakery, a thermostat ensures that the bread is baked at the right temperature. But the most familiar type of thermostat is the one on the domestic gas cooker, which is used to control the temperature of the oven. All that can be seen of it from the outside is the setting dial, which fixes the temperature inside the oven. The main part of the thermostat consists of a rod fixed inside the oven where the heat of the burners can affect it. This model shows the effect of heat on a thermostat rod. When the flames have heated it to a given temperature, the gas supply is cut down. After a while, the rod begins to cool, and the gas supply is again increased, thus keeping the temperature constant. The working of most thermostats is based on the fact that metals expand when heated. Some metals expand more than others. If we take a bar of brass and heat it, we can measure the amount of expansion. Now, if we take a bar of Invar steel, exactly the same length, measure out a section of it and heat the bar, we see that although it becomes longer, the increase is very slight compared with the brass bar. In fact, the brass bar will expand as much as 18 times more than the steel bar. This principle is made use of in the oven thermostat. We begin with a brass tube, inside which is a steel rod. The rod is fastened to the end of the tube and moves with it as the brass expands. At the other end of the steel rod is a valve held in contact with the rod by a spring. This valve is fitted into the gas pipe leading to the burners. When the oven is cold, the tube is fully contracted and the valve is open. As the brass tube becomes hot and expands, drawing the steel rod out with it, it closes the valve and cuts off the gas supply to the burners. To prevent the flame going out completely, a small pipe carries some gas round the valve. This is called the bypass, and it serves to keep the burners alight when the valve is closed. In practice, this bypass is built into the thermostat unit. For the practical use of the cooker, we want to be able to vary the temperature according to the kind of dish to be cooked, so another piece of simple apparatus is included. This is an adjustable screw, which is attached to the valve at one end. The other end of the screw is attached to the regulator knob. When the knob is turned, it causes the valve to move in and out, thus adjusting the distance the valve has to travel before closing. The knob is marked with numbers, which correspond to fixed temperatures at the top of the oven. Here it is at number 7, a medium oven temperature. When this temperature is reached inside the oven, the valve begins to close and cuts down the flow of gas in the same way as we saw in the model. If the oven door is opened, the temperature inside falls. The valve opens, and the flow of gas is increased until the temperature is restored. At a lower setting, the action is the same. But the valve is not screwed out so far and has therefore less distance to travel before cutting down the gas, thus keeping the oven at a lower temperature. Each thermostat setting corresponds to a specific oven temperature. These settings and temperatures are standardized. A chart supplied with the cooker shows the correct number to use for various dishes. Once set, the thermostat controls and maintains the correct temperature during the period the oven is in use.